In this video, we're going to take a look at solving quadratic equations using a method called extracting the root. Sometimes the method's referred to as working backwards with square roots. There are several methods for solving quadratic equations. This video just focuses on that method. I have the steps written out, and I'm going to model some examples. But before we do that, we need to talk about a principle that we apply when solving quadratic by extracting the root. And this says that if you're given x squared equals a, that x is equal to plus or minus the square root of a. Well, this is from a very basic algebraic concept by which we take the equation and square root both sides. The square cancels the square root, and then that just leaves the question of why is it that the square root of a turns into plus or minus the square root of a. Well, just a little bit in terms of that concept. If I had a very basic question that I posed to you and said, I'm thinking of a number and I square it and I get 100, what is the number I'm thinking of? Well, a lot of you probably, if you're just listening to me say that, you're probably saying that the number you were thinking of was 10. Well, in fact, that number could have been 10 or negative 10 because they fit the equation x squared equals 100. And if I just draw that out here that I'm checking it, we see that 10 or negative 10, when squared and plugged into that equation, both give me 100. So the answer to that question is not 10, it's 10 or negative 10. So we say that it's x equals plus or minus 10. Well, that accounts for the plus or minus in this concept. Okay? So it's a very basic idea in that when we are dealing with equations that involve squares, we could get up to 2 answers when working backwards by square rooting. Okay, so you'll see that come alive in this problem as I work through the steps. So let's take a look at the steps. Okay? Steps when you are going to apply the method of extracting the root are: 1, isolate the base with the exponent of 2. It's going to be common for you to see an exponent of 2 in these problems because they're quadratics. 2, square root both sides of the equation. You notice the asterisk here. The asterisk refers to don't forget the plus minus. And then 2, continue to solve for the variable. Okay? So it says, please solve the following equations for x. Number 1, 5x squared minus 30 equals 60. Well, I do notice that the base that I have here that is squared is x, and I'm going to try and isolate the x squared term here. And if you see that, it looks as simple as adding 30 and dividing by 5. So I will do that. So adding 30 to both sides is going to give me 5x squared equals 90. And then dividing by 5 on both sides will give me x squared equals 18. Now, that I have, in fact, isolated the base with the exponent of 2, I'm going to square root both sides and remember to get my plus minus. So this will give me, square rooting both sides, I will get x equals plus or minus the square root of 18. Well, the square root of 18 can be simplified by breaking it into its factors of 9 and 2, which is 3 root 2. And this gives me x equals plus or minus 3 root 2. And from there, it says to continue to solve for the variable. Well, I did solve for the variable. There's nothing really left to do. So you might sit there and go, well, why are you doing that step where you got to say continue to solve for the variable? Well, in other problems, that mindset is a good one because after you square root, you might have more work to do. Okay, as it is a solved problem, we can, as in all solved problems, we can check our answer on our calculator. So I will do that by typing 3 second square root of 2 store x. And then I will type the original problem of 5x squared minus 30 and hope for 60 when I hit equals, and I do. Similarly, if I type negative 3 second square root of 2 and then hit store x, hit second enter on my calculator, that also gives me a value of 60 when I evaluate that expression. So I feel confident about both of those answers. Again, it's not one answer, it's two answers. It's plus or minus 3 root 2. So as I move on to the next problem, where it says negative 3 times the quantity of x minus 7 squared plus 18 equals negative 57, I notice here that the base with the exponent of 2 is a binomial here. It's x minus 7, so when I go to look to isolate the base with the exponent of 2, I try to get that isolated by itself just to start. And to do that, I'm going to subtract 18 from both sides. Okay, and that's going to give me negative 3 times quantity of x minus 7 squared equals negative 75. Okay, and then I need to get that base of x minus 7 that is squared by itself. So now I'm going to divide by negative 3. And that is going to give me the quantity of x minus 7 squared equals 25. Now that I've got this base by itself, it's got the exponent of negative 2, I'll square root both sides, again remembering that I've got to get this plus or minus, the most commonly forgotten thing when doing these problems most likely. So I will square root both sides, take plus or minus. Now you notice in this problem compared to the last one, when I go to do the square root, I'm doing it of a perfect square. So I won't have to go into the margin and simplify the root. So that gives me x minus 7 equals plus or minus 5. And now this other step kind of makes sense that we kind of didn't need to do before. It says continue to solve for the variable. Well, because I had a binomial here, I still have a little more work to do to isolate the variable. In this problem, I didn't because it was a monomial that was squared. But now I just need to add 7 to both sides. And as I go to write this, I'm going to rearrange the order. Instead of writing plus or minus 5 plus 7, I'm going to write my 7 plus or minus 5. Then I'm going to split that into two answers, because it's in fact two numbers, 7 plus 5 and 7 minus 5, which gives me 12 and 2. Again, I could check those answers on my calculator by simply storing them for the value of x, 12 store x, and then typing the original problem, negative 3 times quantity of x minus 7 squared plus 18, and hoping that the result when I hit equals is negative 57, and it is. Similarly, for 2 store x, I can just do second enter to bring back the expression, and hopefully I get negative 57 again, and I do. Therefore, I feel very confident about both of these answers. Okay, so that being said, that is how we extract the root or work backwards with square root. Okay, it's different than the other methods for solving for quadratics. And how is it that we know that we're able to do that? Well, just a little tidbit about that right now. If we look at these problems, the original problems that I've highlighted, okay, we see both of them have something in common, okay? Both of them just have a squared term. There's no quadratic term and linear term in either of them, which would be an x squared and an x term. If you notice, neither of these have singularly x terms. They both just have x squared terms. Here, even though it's a binomial, it's still x squared. This is how we recognize when we're going to need to extract the root, okay, without doing any fancy work to convert the form of the problem we're given. So again, how do you know that you're going to extract the root? Well, what appears in the problem is only just a monomial squared or a binomial squared, but there's no linear term. So enjoy. I hope that makes some sense of this process. As you learn it, you have to be able to combine it with the other processes that you're learning and be masterful at solving quadratics no matter what form you are given. So enjoy.